So I'll be first explaining you how to do reduced joins. That is one concept that we are going to cover. Okay, meanwhile, let me show you the data till Eclipse opens. So basically, so I have actually gathered some data from the external website, which is basically called a movie website. Okay, so okay, yeah, I was just mentioning that I have gathered some data from the movie website. What does it do? So it's basically containing all the movies and ratings and reviews of the customers. I'm sure all of you are aware of some movie review site like IMDb, right? Where you can get the ratings of every movie which are rated by the critics as well as users. And based on that, you can solve some interesting problems. So IMDb kind of websites are actually having a lot of data about the movies, lot of comments that users has given and the critics has given. So they have so much valuable information with respect to any movie so that they can do some analysis on top of that and sell these analysis services to any big production house companies who want to invest in any new project, right? So most of the production companies, movie making production companies are basically now going in a technology way to decide where to invest money based on the result of this analysis done by the MDB kind of websites on the big data that they have. Okay. So what I have done is I have downloaded such data from one of the website. For example, if you see, there is a movies and rating data. Okay, so if you open movies file, it says it has a movie ID, the movie name, the genre details. Okay, so it has a movie ID, movie name, and the genre details. Right, 3 columns are there. Similarly, there is another file which is having ratings. So there is a rating file which has movie ID, user ID, movie ID, rating, and the timestamp. Okay, I'll repeat. It is user ID who has given rating to the movie ID, and of course the rating and the timestamp. These are the details which are basically available with respect to the rating file. Now, if you look at this data, if you just count number of rows in this file, movie file is about 4,000 records. So it has about 4,000 movie details, and the rating files has about 1 million record. Okay, it has 1 million records, 1 million ratings basically. Okay, so that many customers has given rating to the different movies. So we want to use this data to solve some problem, let's say, right? And the problem is, see, till now we have discussed in MapReduce where we have taken one file as an input and then we used to generate an output by processing that file. So it was always input file was always one actually in the case of MapReduce programs. But here I'm showing you one more example where we can have more than one input file and still we can process the data for both of this file and then generate the result. So the need is we need to join both the files, and then based on the joining we need to basically get the result. This joining is called a reduced site join. I will also help you understand one more join technique after this program. So basically here what we are going to do is we are going to process two files and then generate a result. Now here the problem statement is, let's say I have a movie file which contains movie ID, genre details and the movie name. And I have a rating file which contains rating given by every user to the particular movie. So based on these two information, let's say I want to solve a problem where I want to find out what are the top movies which are rated as 5, that means the best rating by the users more than 100 times, right? If you can get me all the movies who are rated as 5 more than 100 times by the users along with their genres. Because if you get me the details, I can sell it to the, let's say, one production house company and tell them that, see, this was happened in the last one quarter where these were movies as rated as highest rating from these genres by the maximum more number of users. So it will give insight to the production house companies that, okay, where to invest in their money in for the next project. They can easily find out that, okay, these genre movies are liked more by the people, so let us do something in this genre. So that is the business problem. Business problem, I'll repeat again. Basically, we wanted to find out the list of movies which are rated as 5 by the by more than 100 times. Okay. List of movies rated as 5 more than 100 times and along with their genres. That is what I want to solve. So is everyone clear with the problem statement? Any questions? No, Raj, problem statement is only one. Okay, get me all the, I'll write it here. Let me just write it here. This is the problem statement. Get the list of movies along with their genres who are rated as 5 more than 100 times. Is that clear now? Okay, so let us uh, understand how do we solve this problem. So as you can see, one of the file, which is let's say a movie file, has movie ID, movie name and genre details, and another file, which is a rating file, will have actual ratings given to that movie by users. So we need to make use of both these files, because one file we need movie genre detail, another file we need actual ratings. Now, if you look at these two files, which is the common column between these two files? Yes, that's correct. Movie ID is the common column. So if I want to join two tables, let's say in RDBMS, you need to find out the common column, right, based on which you can do the join, that which has a primary key foreign key relationship. Same thing we need to do here also. We need to basically find out a common column which we already have, which is a movie ID. Based on that, now we are actually trying to solve a problem. What problem we are trying to solve here? We are going to now process both the files and then understand how do we join both the data like genre details and rating details. So one important thing is, if you have let's say more than one input file and if you want to process all of them using a single MapReduce program, then you need to first make sure that what is the data format in all the input files. I mean data structure. See, if you observe movie file, it has movie ID, movie name and the genre details, which means it has three columns, right? If you observe rating file, it has four columns: movie ID, user ID, ratings, and the timestamp. So obviously, the column order and the name of the column, everything is changed here in both the files, right? So whenever you have such scenario where you have multiple files and all the file contains data which is not very same, exactly same, or which doesn't have the same number of columns, if you have such kind of problems, then you need to, and still if you want to process both the files in the MapReduce, then you need to generate multiple mapper class. Okay, till now we had been writing one mapper and one reducer. Now you have to write more than one mapper class. Each mapper class is responsible to process each input file. For example, if you have a movie file, I will have a movie mapper to process movie file. For rating file, I will have a rating mapper. And both of these mapper class will process them individually to generate some intermediate output. Okay. So now what should be the key and a value? How do we decide that? So this is what I'm going to explain you for this problem. So if you can see here. So I have two mapper class, a movie mapper, and now I told you why we need multiple mapper class. So a movie mapper is one class which is going to process movie file. Now what is the output key value that it should write? See, remember both these files will have a common column as a movie ID, which is going to be our join column. So we have to make sure that we intelligently write keys and values in such way that it can be joined automatically. For example, here I'll be writing movie ID as a output key and the value will be the genre, because I need genre also. So movie ID, let's assume, is 100 and the genre is, let's say, action. So this is the output key that I'm going to write, output key value from the movie mapper, 200 and comedy. Now let's come back. Okay, let me just, sorry, I have to just write it in a way where Yeah, 200 comedy. Now you have rating mapper. So you have, let's say, each movie rated by, again, movie ID is the column, but actual rating were given for that movie. Okay. Let's say these are the ratings given by each user to that different movies. Okay. So this is the output key value from both the mappers. Okay. Now since we are writing the same output keys from both the mappers, automatically all the values, if you observe here, movie ID is 100 from rating and movie mapper both, right? The data will be combined in shuffle and sort. So what will happen for 100 key? It would be something like this. The action, right? You have 1, you have 2. Then of course movie ID 200, you have comedy 5, 4, 3. Okay, this is how your data will be combined and then it is given to the reducer. Where reducer will basically process this data, it has to go iterate through all this and then generate the final output. So what happens here is the way we are writing our key and value in such an intelligent manner so that in shuffle and sort automatically the framework itself takes care of joining both the data. Right? See, our aim was to join both the data from both, I mean, basically data from both the files. So that is why we are writing our key and value in such a way that key will be the joint column, which is movie ID, and the value is different for different mappers. So what happens in shuffle and sort? It always combines all the values for the same key, and that is why it was able to combine the genre and the rating details for that key, and that this is where join happens. That is why it is called reduce side join. The join happens in the reducer end. Is that clear, everyone, till this point? Any questions? Yes, Raghu. We will rely on framework itself to do the join. We don't need to do any external join. I'll also show you the technique where we need to do external join, but here we don't need to do external join. That is why it is called reduce side join. So Raghu, if you have multiple keys and if you want to join based on, let's say, multiple columns, then you can write them as a composite key, right? That's why I have given you one example on the yesterday or day before yesterday, if you remember, right? We have a composite key, right? Product city combination as a key, if you remember that example. So here you can have multiple columns as one key. You can just make them as a composite key. Then you can join based on this as well. Is this some kind of interview question that you got? Okay, okay. Raghu, I mean, we need to think a little bit on that because see, what you need is you want all the data from both the tables. In that case, actually, I would suggest not to have a common column. You understand? Even if you have a common column, you should not join based on that column. Okay? And then only you can get both all the data from both the tables. So you should not write key as a common column between both the files. In that case, you will just get inner join. But if you get only all the records, then don't put a common column. You can just put movie ID as movie mapper out key, and in rating mapper you may use user ID as a key. Let's say. So in that case, what happens? All the ratings were given and all the genres were given, irrespective of whether they come match or not. So that is how you can get it, right? So it's all about how intelligently you decide which key to take, which key to avoid. Okay. So basically what you need to do is you need to take a custom object as we discussed in the yesterday session, right? Movie and rating. So movie class will have, movie genre name, the name of the movie and the genre detail because all the columns are, only these two columns are there in the movie file along with movie ID, right? So this is one object you need to create, which you need to set it as an output value. And in the rating mapper, you need to set rating as an object which contains actual rating, which also contains the timestamp and the user ID details or username, date or timestamp when the rating has been given. Correct? So that likewise you can have all the columns in two objects, and you set that object, corresponding object, as a output value for that mapper. So that what happens when you're combining when you're joining for all the for 100 as a movie ID key, you are getting one movie object and one rating object, two rating object in fact, because it has two ratings, right? One object will have rating as one, another one has two, of course different user detail and rating. So this is how you can get all the column details. Are you getting this, Raghu? So you need to use custom type basically, the way we have seen in yesterday's class. So any further questions on this? All right. So this is what would happen internally, okay? Now there is little importance thing which we need to discuss, which is, let's say, let me just delete some space so that we can. Okay. Now here if you observe, right, say we understood that what is the key value we need to take from movie mapper and rating mapper, and we know that all these values are combined and they are given to reducer. But in reducer, when you get this data combined, you get the genre name, you get the rating details. All this data, when it comes to reducer, as a developer, if you want to parse this, how will you know which is the genre and which is the rating, right? Because some data is string, some data is integers and all that. Now, if you add tomorrow a name also along with the genre, then it will become difficult to identify which one is, genre, which one is rating. So, one best solution is to use the output value of each mapper as a composite object, as a POJ object, basically. The data type, custom data type that we have seen yesterday. Same way you need to write that kind of class and put all the fields in that class, and then use that object as a custom data type for any value, output value that you are writing from that mapper. But if you don't want to do that, then there is another better way to do it. You can just pass some flag when you are writing any output value. For example, let's say I am passing genre details and rating details as an output value from movie and rating mapper. So I need to inform to my developer in a reducer end that this is the genre and this rating, this data is coming from rating. So what I'm doing is, let's say I'm just prepare the data with some hard-coded text. For movie mapper, I have done m/t. For rating mapper, I'm doing r/t. So what is happening? For movie mapper, it will become m/t. This is r/t. What is R and M? R stands for the rating. Basically, I'm just informing that if there is an M, that means it's a movie. There is R, that means it's a rating. What is slash T? Slash T is just a separator. It's a tab character which is put between these two words so that, see, what happens is now your data will be coming in this fashion from shuffle and sort to the reducer. So it's all string data, text data. When you're iterating through them, you just need to take, let's say when you're iterating through all this data, you will iterate through first this data, split it based on the tab. Once you split it based on the tab, you will get first part which is M. If it contains M, that means obviously second part will be genre. If it is R, then second part will be the actual rating. Got it? So that is what happens. So basically when we are covering, we have to do it in this fashion. So we are just passing the indicators to every record so that in reducer end when we are programming, it becomes easy for us to identify which is movie genre details and which is the rating details. Are we able to follow this, what I have done just now? Any questions? So Raghu, as I said, for this particular problem only you are doing it this way. Otherwise, you can just take custom objects. I'm just showing you different techniques. Which is more efficient, that you can always decide later, depends on your use case. Of course, custom object is the most efficient way, but this is also one way you can solve the problem. Okay. All right. So let us start programming for it. Okay. So I'll be writing your code now. So here I'm taking a movie mapper class first, and as you know, this is the data which comes as an input value to the movie mapper file. This is my output key. Output key is what? Movie ID. Let's take movie ID as 100 and value is M/T, the actual genre. If I just consider the genre as, let's say, animation, so it should be animation. So we'll decide the types accordingly. It will be long writable, it will be text, the movie ID which is let's say int writable, and the text. Okay, so let me just create an object and writable. Okay, so basically this is the movie mapper class that I have written. Very simple, just take the entire row as a value, split it based on this character, and then you get all the columns, set the appropriate column as key and value. Key is movie ID, which is 0, which I'm converting into integer, and then set it as a key, and the value is the animation, which is the genre details, and I'm setting it as a output value, but I'm prefixing it with M/T. Okay, so this is my movie mapper class. Same way, let us write the rating mapper also. On the similar lines, we will write a rating mapper. Okay, this completes my rating mapper. I've just done minor modifications and my two mapper classes are done. Okay. Is everyone clear with these two class, movie and rating mapper? Any questions here? Yes, guys. So, oh, okay. Thanks for pointing it out. It should be R/T. Thank you, Nikhil and Shiva, for pointing it out. Okay. As an output value, you are prefixing it with R/T for the rating mapper. Cool. All right. So let's start writing a reducer. So what I'm saying is basically, see, we need to print only those movies in the output file which are rated as 5 more than 100 times. So that's why I'm just getting this count of rating also, which is more than 100. I'm just giving some number here and the genre details. So only the output file contains this record if it's rated as 5 more than 100 times. But this is how your input data comes, right? When you are writing it, this is how the key and the values comes after shuffle and sort. So based on that, we have to write our reducer logic. Now what you need to do, you are getting this kind of text object, list of text objects. So you need to iterate through them. Okay. For every value in this values array, what you need to do, see, when you're iterating, you'll get first record like this, which you need to split based on tab to get the first record, which is M or R. So I'll get parts. Now what I'll do is, if my first part is, let's say, M, then obviously if this is M, then second part have to be the genre. So I can also take the genre string genre, and I'll just take genre value here and store it in one variable like this. Else if there is an R, then if it is a reducer, if it is R means rating, then you will just say count is equals to 0. Increment the count as and when you hit that. So now here I need to check one more thing, which is if the second part is 1, then you will have to increment the counter. Not 1, sorry, 5. If the rating is 5, right, and we need to check how many times it is rated as 5. More than 100 times, then only we need to write. That is why I'm taking a counter and I'm checking if it is 5, just increment that counter. So that's it. That is what I need to do in the for loop. At the end of this for loop, once my iteration completes, I should have my count value, so I can just do this. Out value dot set. I'll just say genre is equals to Hello, am I audible, everyone? Okay. So basically, I was just saying that this is the reducer code you need to write, right? And finally, I'm setting the genre and the total rating count here. And I'm setting it as a context.write output key value. So basically, this is how I complete my reducer code. Is everyone clear with the reducer code? Any questions on this? Good observation, Raghu. I think I missed that. Thanks for pointing it out. Is that clear now? So Raghu, basically after this for loop, right, you would have found out the total count, like how many times rating 1 has come, rating 5 has come. Now if the count is more than 100, it can be anything, 100, 105, 3, 4, 10, 100, 200. Anything more than 100, you just write that output key value pair into the final report. Okay. Okay. So in the output, what I'm including is I'm including the genre details and the total rating count. Total rating count is total rating count for that movie ID. It should be more than 100, but it could be 101, 2, 3, 4. So I just want the exact count, like how much was the rating count, right? So that way also we can figure it out that, okay, all the movie details which are rated as 5 more than 100 times are only included because their count is always more than 100. So anyway, that is the reducer code. In the driver code, what do you need to write? So in the driver code, it's as we discussed many times, it's configuration. But there is some minor change you need to do in the driver code compared to other driver codes that we have to write. Now here you need to take the multiple input class, which basically takes the job. I have to pass two arguments, right? Argument 0. You need to also tell okay. So as you can see, since I have to read multiple input files, I am using multi-inputs. Here I am passing first argument file as a movie file, which I am mapping it to movie mapper. This is where you are telling Hadoop that please use this mapper code to process this input file. Okay. Uh, Vishal, your question you are asking was related to reducer. Okay, let me go back to reducer. You are saying, can you explain this for loop? So, Vishal, this is how the loop comes, right? You have all the values, which definitely has /t in that values. So you just take every value and split that value based on tab. You get two parts. If first part is M, the second part is genre. If the first part is R, you increment the count for the rating if it is 5, and then you are writing it at the end as an output key value based on if the count is more than 100. Okay. All right, so here I will write my output using, yeah, this is one thing. Then I have rating mapper also, and of course there is a so this completes my driver code. What I am doing here, I'm adding two files as like multi-input paths because I want to read the data from more than one input file, and assigning it to corresponding mapper, movie and rating mapper. Then I am assigning it to setting it to the output format, the output path, and then submitting the job. That's it. Okay. So this completes my entire reduce join code, multiple mappers and one reducer, right? So any questions on this code before I execute it? Where do you want me to add the debugger, Raghu? If you want to add a debugger, you can do it here. Let's say for every value, right? But it will be too many values because there are too many ratings also. So I don't want to set it here. I'll set it probably in one of the example. Let's say M/T. Right? If it is movie, there I will set it so you'll get one value at least M/T and the genre details. Okay. No, Raghu, here we are having multiple mapper class, so we are setting it like this in multiple input itself. If you have more than one mapper class, you can't set it using set mapper. I'm sorry, it was question from Raj. So sorry, Raj, but yeah, we have to use multiple input format. Okay, so now let us start debugging it. But first we'll create a jar. I have already put a log statement, so it will be available in the logs. Let me go to the HDFS and see if the data is there. It's not there, so I need to add it. Now we can start executing it as a jar, Hadoop jar, jar. They give the full path, and then there is a class which you are going to use. So rjoin is the class. Input path is, of course, first file is movies. So as you can see, first file is mapped to movie mapper and second is mapped to rating mapper. So that's why we have to be very careful when we keep this order. Okay. So now we are executing it. Yes, Raghu, the names are sensitive. Okay, so we got the output. Just 1 second. I'm sorry, Mary, I couldn't see your response. Let me just quickly uh, see it and then give you the output, give you the response basically. So Mary, you did not compile it properly. You still have compilation errors, and that's why it gave this issue. Okay. It says unresolved compilation problem. So you need to in fact go to the 59 number line in your code. Okay, and that's where you have some issue with your compilation. Okay, sure. All right, so we got the output. We'll check it here itself. Okay. So as you can see, we got this data, genre, and the count, which is more than 100. So all the ratings which were rated here, their count, everything, we got it here, which is more than 100. Okay. And you can also go to the resource manager tab, where you can find out that debug statement that we have printed. For every m/t, we got that value printed, which includes tab also. So this is the job R join. If I go to the history, I have printed it in that statement. I have printed it in the log, right? If you see here, it was printed it in the reducer. Sorry, yeah, here. So this one, values in reducer. So we have to go to the reducer logs. It's still taking some time. Go to the reducer, reduce ID, logs. As you can see, m/t, right? This is a tab. It doesn't represent tab. It was giving the tab as a space. Okay. So all the data which had a tab were printed like this. I have put it in the only the if condition where it matches with M. Otherwise, what would have happened? It would have printed me for all ratings and everything, which was like too many data. That's why I have just put this in the M/T. So that's why, you could see only genre details, which were separated with tab. So is everyone clear? Raghu, are you clear with this? You wanted me to put this statement. Okay. So this completes reduced join techniques, okay, that we have. So ignore that part, Mary. Just look at this part. This is the genre details and the rating. This is what we wanted. Okay. If I had taken the correct data type for movie ID, it would have given me the correct movie IDs. So that is fine. That's not an issue. Our problem is solved by taking this. All right. So let's take one more example. Just 1 second. So there is a simple file called test.log. It has certain messages, okay, some log statements. As you can see, it basically prints some statements as good and bad. I mean, it says this is good record, this has error, this is bad record. So let's assume that we have some such kind of data, and I want to find out how many are good and how many are bad records. So how do I write that program? So by the way, all of you, when we executed this MapReduce program, for example, here, right? Anyway, you would see that. So basically, you remember when we execute a MapReduce program, it will give some statement. So it will be something like this. Let me just execute it one more time. I just wanted to show you the output which is being printed. It will take more time, so don't worry about it. When it prints, I'll show you that. But anyway, see, it gives you some counter, right? That number of mapper tasks to be executed, number of reducer tasks, how many bytes were shuffle and sort. These are all called inbuilt counters. Okay, it gives you the count of records which were processed at every phase of MapReduce. But you can also write your own custom counters in some problems, and you can display that statistics on the console itself. So that is what I want to do. I have a file which contains some good and bad records, and I want to process it and count how many good and how many bad records are there using counters. Right? So whenever you want to analyze any data, you can use a counter to analyze that data. For example, let us write a custom counter example. Uh, this was the file. So what I will do, I will use my mapper code to process each and every record, and then I will find out which are good and bad record. Now you don't need to use a reducer here because I want to use a counter to count that stats. Okay. See here, this is what I mean by counters. All of them which are printed once the job is executed successfully, right? There are some file system counters, some job counters, map reduce counters. There are all these are called counters, okay, and it will give you number of records which is processed. Same way, I will add some custom data here. It should give me number of good and bad records. That is what we mean by counters. So whenever you analyze any data, sometimes it is required to analyze it based on the some counter statistics. So that's why counter is useful. Okay. So I'll be basically writing one enum class. Record check is a counter. It has two. If you don't know enum concepts, it becomes difficult to understand this, but it's fine. Just try to understand the concepts what I'm doing here. This needs your Java skills little bit. So I'm taking one enum which is a record count, record check, just like a class, but it has its own objects, define objects. And then you can take a counter class. I'll just explain you what I'm doing. In the make function, I'll basically check if the value contains error. I'll just say if the value dot toString dot contains error, or it basically contains a bad word. That means it's a bad record, right? So I'll just mention it here that if it is error, I'll just say if it contains error, then I'll just say bad. So I'll have to increment the counter. I'll do this way. Context dot get counter record check dot bad dot increment 1. Basically what I'm doing is I'm incrementing the bad counter by 1 if it contains error or bad records. Similarly, if in the else part, I can just increment the good counter. Okay. This completes my mapper code. So what I'm doing, every line that I'm passing, I'm just checking if it contains error or bad record, and I'm just incrementing bad counter, otherwise I'm incrementing good counter. And then finally I'm writing that output as a, I don't need to write any output, that's why I'm using null writable. We already know why to use null writable in the earlier examples. So it will not write anything, by the way. I just need to set the counters. That's why I'm doing it, okay? Now, what is the I just copy paste the main method from some other code. I already have written this code, so I'll just do that. Okay. So it is taking a configuration object, job object. It sets the main class, the mapper class, output key type, value type of the mapper. That's it. File input and output format, right? And then the most important part is this, which is I want to print all the counters, right? So in fact, you don't need to write all this. Just type this. It should work. This will only print. You don't need this out statements. So what I'm doing, I'll get all the counters through this job. All the counters means what? It will give me all these counters. From there, I just want to print this good and bad, right? Which I purposely I want to print, which I have set it. So it will just print the value for this counter. Okay. So this is just a small program which I have demonstrated just to explain you how do you write a custom counter. Many times this can be useful when you want to solve some problem. You might want to also check the counters, and you can set it to the counters in this fashion. Okay. Is that clear, everyone? Any doubts on this program? Yeah. Any doubts anybody has on this program? Let me write this input file. We'll execute this now. I'll write the input file in the SDFS. Then we'll execute this program. So I'll just say Hadoop jar. the input path which is test.log, the output path I can, oh, there is one more important thing. I don't have a reducer, so I need to set the reducer as number of reduced task as 0. Okay. So I need to re-export it as a jar and then I can execute it. Let's say counter. Okay. So this is what I'm going to execute. Let's see whether it prints the counter on the console or not. Okay. Here, as you can see, it has printed our own custom counter. Bad is 2, good is 3. Okay. There are 3 good records and 2 bad records. That is why it has printed that way. So we were able to successfully print the counters, as you can see here, right? Along with the system counters. So are we clear on this? How to write a counters? Any doubts anybody has on this? Yes, Vishal. As you can see here in the code, the get counter method, if you observe, will take enum as a parameter. That's why we expect enum only here. Okay. Yeah. Any further questions on this? All right, everyone. So this completes the counter. Now we'll see one more technique on MapReduce, which is called map side join. But before that, we'll take a break now. We'll come back after the break and then continue the session. Okay. So let's take a break now. See you all after the break, and we'll continue the session after the break. Is that fine with everyone? Okay. See you all after the break. Thank you. Yes, Mary, I'll send it. Am I audible, everyone? Yeah. Okay, so we'll be basically now seeing one more technique which is called map site join. Okay, so I'll help you understand how does a map site join work and how do we achieve that. So let's just open the first the import data set. So we already know the transaction file, right? We have used it in two programs earlier, which is basically a user ID, product, and city, and transaction date, and all that columns. Now let's say I want to find out the maximum transaction done by every user, okay? Or let's not even worry about that. Let's not even do any further operations. Let's say you just get me the contact details for every user along with the products that he has purchased. Simple. No reducer operation is required in this problem. I'll repeat the problem statement. Get me the email address, all the contact details of every user in this file. For example, if you see the user ID 400100, you can just say the get me the product details, which means this is the product he has purchased for $100 in this city and what is his email address. Similarly for other users. So you just need to get me this detail. But here the question is how do you get the email address? This file does not contain the contact details of the user. It just has the user ID details. So you need to basically join it with another file which is called users.txt. I have created a sample file for each user ID. You have a unique user email ID as well as the username. So there is a user related information available in another file, and there is a transaction related information available in another file. These two files we need to join to solve this problem. So is the problem statement clear with everyone? Okay, fine. So here we are going to join two files, okay? We have two input files and we want to join them to get the result. So we know that yes, how do we join two files? We already have seen one technique called reduce join where we can implement the same technique to solve this problem, right? But I don't want to use that technique. There is another technique available which is called map site join, and we will be talking about that. So what is a map site join? Map site join means you are going to join two input files based on the common column between them, right? So it's a typical join only. But the catch here is if you observe one of the file which is a transaction file will have all the transaction data, another file will have users data. So can you tell me just by the domain experience which file do you think will be a very huge file and which file does not have so much record out of these two files? Can you tell me that? Yes. Very good, Vishal, Raj, Nitin, Mary, Shantanu. Yes, that's correct. All of you have given the right answer. That's good. So basically, the transaction file will be a very huge file, as we know, because every user's data, every user who does any transaction will be listed here. So he can do more than n, I mean, 10, 20, 50, any number of transactions. So for a given user, you may have n number of transactions. Likewise, if there are n, m users, you can have n into m transactions. So there are too many transactions which can be available in this file. So it's a huge file, obviously. But the users file will be having only one record per user. Even if you want to add any changes or update any record, it is just still the same record. So you're not adding multiple records in users file. So it will be relatively a small file, right? So when you consider these two files, we can clearly say that users file will not have too much records, whereas transaction file will be very huge. Now, whenever you have this situation where you need to join two files, where one of them will be very huge and another file is small file, in that case, you need to actually start using a technique called map join. How does this technique work? So let us understand that part. So I'll just explain you that technique here first, then we'll start understanding the programming side of it. So here I have a master node, right? Let's assume it is a job tracker, and these are all task trackers. And assume we have one big file which is a transaction file, right? Which we have just discussed. We want to process it. Let's say it is divided into three blocks. Block A, B, and C. Block A is here, B is here, C is here. Now you also have, this is my transaction file which I have stored in SDFS and it was divided into multiple blocks like this. Now there is another file called users file, which is a small file. Users file, which basically is a small file, and I have to also join these two files to get the final result. So one file is already stored in SDFS and it is available in the form of blocks. Now in the map side join technique, what you need to do is, whenever you have a scenario where one file is small and one file is big, what you do is you basically use a concept in MapReduce which is called distributed cache. What is distributed cache? Distributed cache is nothing but it is one physical folder available in every local file system of every task taker machine. There will be a cache folder available in all these machines. Whenever you store any file in this particular directory, okay, not any other directory, but only under this particular location where distributed cache is stored, then you can read the entire file from your map or reduce task, okay? Otherwise, it is not possible. So basically, what I'm trying to say is, when you have one small file, what we do is, we will first load that small file into the distributed cache area of every machine. So basically, when your program starts, when you submit a jar to job tracker, right, as a client will submit a jar to the job tracker, the job tracker first creates map task, right? But before it creates a map task, it will find out that, what is a small file. It will find out that users is a small file. So it will basically, yeah, it will basically copy that users file into the each and every task taker machine. So what happens here is, it will be something like this. When a client submits a job to job tracker, the job tracker will basically transfer the user's file to each of the machine, okay, under this cache directory, users.txt. Here also users, here also users and users. Basically, the entire file itself is copied to the local file system of every task taker machine under distributed cache area. Okay. So whenever you start a program, automatically this file is distributed to all the slave machines and it will be residing in the distributed cache area. Now what happens? Now we have one big file which we want to process. So job tracker will, let's say, assign map 1 task, map 2 task and map 3 task to the 3 machines where the block ABC of this file is stored. Okay. So here map 1, map 2, map 3 are assigned to these tasks. Now what happens? Map 1 is going to process all the data from block A. Map 2 is going to process all the data from block B. And map 3 will be processing all the data from block C. Correct? See, remember, this is one transaction file, this is one user file, and we want to join them. So map1, when it is processing, when it is reading every record from the block A and processing it in the form of keys and values, it will first load the entire users.txt in the memory. So assume there is a memory RAM section of this machine. What it does, it will put the entire users.txt file into the memory and it will join that file with this every record of the block, and the result of which will be written into the output file. So what happens is the mapper task will first load the smaller file which is in the which is a user file which will be available in the distributed cache, will be loaded into the RAM of that machine. Entire file itself will be loaded. Because it's a small file, it is important that you load entire file in memory and then you join that data with every record of the block B of transaction file. Now the advantage of storing it into distributed cache or loading it into memory is because, see, it's always better to load entire data into memory so that in-memory processing will be faster than going into the disk every time and then comparing the output, right? That is why it actually loads all the data in memory. Same way blocks map3 will also do the same thing. And in memory itself, it will join the entire file with every record of the block A, and then the result will be written as an output file from all the map tasks. This output can be written directly to the SDFS if you don't have any reducers. Okay, so this is how a map join technique works. Is everyone clear with this technique? Any doubts on this? I'll show you the program, but are we clear with the technique? Sure, Nitin, I'll repeat it. So, see, the problem statement is we have two files. Let me just repeat for the benefit of everyone. We have two files, a user file and a transaction file. Each user has done some transactions, so what I want to do, the output report should contain this data. I want the product purchased by every user along with its amount details and his email address, his contact details. For every record, I want these details to be available in the final output. Correct? Now here, you need to join this file to get the product and amount details and the user ID details, and another file called users you need to join this to get the email address, which is its contact details. Now, when you have to join both the files, either you can use reduce join technique or map side join technique. But if your one of the file is smaller, as we discussed here, that user file will always be smaller compared to the transaction file. Hence, what we do is we can use a map side join technique where we copy the bigger file into SDFS, so it is divided into blocks, and the smaller file will be copied into the distributed cache folder of every task taker machine. There is a API through which you can do that. I'll show you how to make it available to cache. Okay, so basically what happens here is client submits a job to the job tracker. The job tracker will create multiple map tasks based on the blocks available for the bigger file. It will create map 1, map 2, map 3. Now here, the map 1 is trying to process block A, every record of block A, but at the same time, okay, so basically he is assigning all the map tasks to process the major blocks of the transaction file. By doing that, when M1 is processing every record of block A, you have loaded this users.txt, which is a small file, into the distributed cache. So mapper class will also load this entire small file into RAM and then join that with every record of block A. This is happening parallelly with all the map tasks, and that's how it generates the final output. So this is called map side join. Basically, you do the join at the mapper end only. That is why it is a map side join. There is no reducer executes here. Okay. Now to answer your question, Vishal, yes, it is possible to have multiple files, put it in the distributed cache and directly load it into the mappers class in the memory, provided these files are very small and they can be loaded into memory. Okay. Shantanu, there is no calculation, but then you need to be aware, right, what is your RAM size, and if it doesn't fit, then it will give you out of memory exception. So normally the RAM size which you have, which will be around 2 GB to 4 GB size, so obviously your file is more than that, then it will not fit, something like that. Okay. Then you need to store it in SDFS and then process it the way we have learned so far. So Nitin, are you clear with your okay. So Vishal, what do you mean by cache flush? I didn't get your question. Oh, okay. So removing file will not happen immediately. It will happen periodically. It will purge them as and when it is, needing it to purge. So that is like internal to the system. The purging policy by default, what is the purging policy that it use? Accordingly, it will purge these files from the distributed cache. Okay. Yes, that is correct. Okay, so since no questions, we can start programming for it. Okay, I'll show you the code right now. There is already a code written here. I'll just copy the code here, directly make it available. Let me just open a new window. This is the map join code. Okay, so let us understand one by one what we have written here. So here I will start with the driver code. In the driver code, which is the main method, what you are doing. So you are taking a configuration object, you are taking a job object, then setting number of reduce task is 0 because there is no reducer, setting the jar class, the mapper class, everything is same. Map output key value type, input format, output format for input and output path location, and then submit. So everything is the same as we learned earlier as well, except this particular change, which is the distributed cache line. So what you are doing is you are saying that distributed cache dot add cache file, and you are actually giving some URL. So this is my SDFS part. So first time at least this file should be available in SDFS from where it can be picked up. So I'll just say distributed cache dot add cache file. Please copy this file from this location into the distributed cache of every slave machines. So this line will say that. Okay. And yeah, once you execute this command, yeah, so when you put the file in the distributed cache, it will look something like this. Uh, yeah, here. That statement, when you execute, the job tracker will disperse this file into the distributed cache area of every machine, physical machine. Clear? That will happen after the execution of this statement. Okay, so that's how I load the file into the distributed cache. For that, I have to copy the file, users file into the data directory, so that it will be picking up from there and copying it to every local machine, every local file system of the slave machine under distributed cache area. I'll also show you when we execute this program. I'll take you to this location where we'll see whether this file will be added to this location or not. So is everyone clear with the driver code? Any confusion with driver code? Alright, so now we'll start understanding the mapper class. So as we discussed in the mapper class, what used to happen, once you have put this file in distributed cache folder, the mapper code will do first one important thing. It will load the entire file from the distributed cache into the main memory, into the RAM, right? Entire file will be loaded into RAM, which is user's file, and then it will join that file with every record of the bigger file. So first step is put the data into the RAM. So for that, what it is using, I am having a mapper class which will have multiple methods. One is called setup method. Till now we have not seen setup method, so I'll be actually introducing one method called setup method. What does setup method do? So setup method basically will help you to actually execute this code much before anything else. So for example, if you have, let's say you want to copy these smaller files into the RAM, right? That is just one-time activity, okay? See, for example, let's say block, let me just delete something if it is possible. Yeah, let's say take this example, block C. Now block C has assumed 100 records. For every record, map function will get called, correct? So map3 will call map function for every record in block C. But what we have discussed, we are loading this user's file into the RAM of that machine, where entire user's file will be available, and I will join that with every record in the I'll join that with every record in the block C. So that join logic will be in the map function. Now map function will be called for every record. But does it mean that when every record, when I have to join that with user's file, does it mean every time I have to load it into memory? No. I can load entire file into memory only once, and then I can directly join the data from this block to this file which is already there in memory. I can store it in memory. So what I'm trying to highlight a point is, whenever you have a requirement where you want to do some pre-processing before your all the data, all the records starts processing in a block, before basically a map function gets executed for any record in a block, if you want to complete some pre-processing, then you need a method called setup. So setup method will be called only once. Remember one more time, if there are 100 records in block C, setup method will be called only once, not 100 times. But map method will be called 100 times. So setup method will be called first, where the logic written here is what? We have basically written a logic where we are using a distributed cache API to get all the cache files, all the files. Basically, see, as we discussed, there may be a possibility that there are multiple files stored in the cache location. So I want to load all the files, and then I will get all the files. Now here what I'm doing, I'll iterate through the files and I'll check whichever file name matches with users.txt, that will be my file. So under that, I'll just read that file content using a buffer reader. It's a normal standard Java IO functionality to read any file. Okay. And then once you read that file, you read line by line until the line is null. What you are doing, basically it's just typical reading. So you take one record and you split it. You split it based on the comma, you get different tokens. Token 0 is your email address, and token 0 is your user ID, which is first column, and the second column is an email address. So I'll just use that as a email address. I just need token 1, no need of any other tokens. Okay, so I'll have ID, user ID and email address. What I'm doing is I'm creating one hashmap object, and I'm putting that ID and value as a key value in that hashmap object. And then I'll go to the next line. So likewise, every line, for example here, every line in the user's file I will basically split it into the key and value. Key will be user ID, value will be email address, and those key value will be added into the hash map. So I'll be maintaining one hash map data structure in memory which holds these values of the user's file. That's how I basically load data of user's file into memory and store it in memory using a hash map. Okay. So this completes my setup method. Is everyone clear? How did we load data from user's file? Any questions on this? No, Vishal, there is no prerequisite that file to be sorted. Why do you need that prerequisite? You can put any file, any order of data. No prerequisite of sorting it. All right. Now we will have a map function. So after that, once you loaded the data in customer address info hash map, what you do, it's like this. It will go by every record in the block C and it will call map function on top of that. That is what happened here. So you are calling map function, get every record of the transaction file, right? And split that record again. Split it, get the customer ID, and what you do, you want a corresponding email address. Now you already have stored the hash map from the user's file, which has a customer ID as a key and the value is an email address. So if you want to get a corresponding value from the hash map by passing a key, you just need to pass a key here. So I'm just saying map.get of customer ID, which is a key. So I will get a corresponding email address, right? This is my email address that I'll get. Okay. So once I get the email address, right, then I will use that in the output value, and I will also set other parameters like amount and product in the output value. Correct. So this statement which you are doing here is called join. Here we are joining the data from a transaction file with the user's file, because you have already loaded the entire user's file in the form of hash map. So this line means joins. Are we clear here on the mapper code? Any doubts? This is called map side join, by the way. Okay, so this completes the entire map side join technique which we have covered. Now I'll be executing this. I'll create a jar file. export it as a jar. Before we start executing it, okay, I need to show you something, which is what is the distributed cache and where it is available. So remember in the first day we discussed where Hadoop code will be installed and where all the configuration of Hadoop will be installed. So there is a file called yarn site.xml, and I have shown you this on the first or second day itself, where you can see there is a directory available, which basically means these are the local cache directories. So it is a distributed cache directory where all your distributed cache files will be stored in every machine. So if I go to this path, if I go to yarn, okay, so right now there is no files available in the file cache. This is the location which is for the distributed cache files. So whenever I execute the program, map site join program, we will see that under this location that user's file will get copied. Right now nothing is there. Okay, so let us go and execute this program. So I'll go and execute this program. Hadoop jar. Okay, so we just need to give a path of the bigger file, right? I just want to check whether the transaction file is already stored in the SDFS or not. I think it is already stored. Under data, you should have a transactions file. Yes, transaction file is there. Users file is also there. So as you can see, users file, we are already loading it via this. I have given the path in the program itself. So when the program starts, the job tracker will copy the file from this location into the distributed cache of every machine, into the local file system of every machine. So which is that path? This is that path, right? Which I have just shown you. Right now it is empty. You will see that the users.txt file will get copied here when we start the execution. So let me execute this program. When we execute this map site join program, you can see that the file will get copied in the distributed cache here. So as you can see here, it is basically giving the map radius percentage. Now as you can see, you got a new folder created. Just go inside this. You will have a users.txt file available here, right? It has all the data. So the entire file gets copied under this location, right? So this is what we mean by distributed cache. It has copied it and then it has joined it. We got the output also. So you can see the output like this. But this is the most important part, the distributed cache, where your file will get copied at the runtime, right? So we have validated the concept that we learned. And this is the output. So for every record, I got amount, product, and the corresponding email address. Okay. So is everyone clear with the map site join technique? Any questions on this technique? Okay, meanwhile you ask the questions, let us complete the polling also. So can you just quickly fill up the poll? Yes, Raghu, I'll take the XML example in tomorrow's session. Okay? And then we'll move on to the next topic, which is an ecosystem component of Hadoop. We'll start with pig, then we'll go to the hive, and so on and so forth. Right? Yes, I'll do that, Raghu. I'll be sending you all the code that I have covered so far in an email today itself with the data. Okay, so you can practice it. I'll email it to all of you. I could see 2 people have not yet polled. Can you please finish the polling? Now 1 person is left. Sure, Vishal. Thank you. By the way, all these examples that I have covered in MapReduce, right? None of the training, like trainers would cover that because, they stick to some of the course agenda. But then what I do is I cover little extra. I know that these are complex topics, and if you don't get it via examples, it becomes difficult to understand. So that's why we cover extensive programming on this part. Like once you know the core Hadoop, right, which is SDFS and MapReduce, rest of the things becomes easy to understand. Right, so that is why we have covered these topics extensively. Okay, that's good, Vishal. That's good. Mary, yes, after this class, I'll be sending it. Yeah, in just about next half an hour to 1 hour time, you will receive the email. All right, everyone. So that's all I had for today's session. I hope all of you have enjoyed today's session. So thank you. And as I said, let's meet tomorrow at the same time, and we'll continue further. Okay. Thank you all. And please participate in the feedback survey also at the end of the session. So I'll be closing the session and we'll meet tomorrow. Please do all the practice. I'll be sharing all the code with you by today itself. Okay. Thank you everyone. Have a good day. We'll see you tomorrow.